In this video, let us learn to calculate the corrected voltmeter reading for calibrating a high range voltmeter using a potentiometer. And we will also learn to draw calibration graph for the same. Generally, we do calibrate a voltmeter for a low range as well as for a high range. The low range voltmeter falls in the range between 0 to 5 volts, and we increase the voltage in steps of 0.1, 0.2 or 0.2, 0.4. Whereas for a high range calibration of high range voltmeter, the range is between 0 to 12, where we increase the voltage in steps of 1 volt, 2 volt, 3 volt or 0.5 volt. Like we will take the readings for 0.5, 1, 1.5, 2. Okay, now let's learn to calculate the corrected voltmeter reading. So this is the L naught observed during the experiment, that is the balancing length when the EMF of the Daniel cell is balanced. L naught is 549.3 into 10 power minus 2 meters. Here for the high range voltmeter, the voltmeter readings are taken for every 1 volt, 1 volt, 2 volt, 3 volts till 10 volts, and the corresponding balancing length is noted here. During the experiment, we will choose the value of P and Q. The value of P and Q should be chosen in a way that P plus Q should be greater than 4 times the P. This is the condition for choosing the P. For our device, we have chosen the P to be 100 ohm and Q to be 900 ohm throughout the experiment. For the first value, let us calculate V dash, that is the corrected voltage reading. And the first reading of 1 volt, the value of L is 52.3 into 10 power minus 2 meters. I have already mentioned what is L naught, 549.3 into 10 power minus 2 meters. And we know P is 100 ohm and Q is 900 ohm. First let us calculate P plus Q divided by P. We know P is 100 and Q is 900, so it is 1000 divided by 100 will give us 10, and ohm and ohm will get cancelled. The ohm in the numerator and the denominator will get cancelled. We will get a constant value of 10. And the formula to calculate the corrected voltmeter reading is 1.08 divided by L naught into L into P plus Q by P times volt. So now let us substitute the values for 1 volt. So 1.08 we know, and L here is 52.3 into 10 power minus 2, and the value of L naught is 549.3 into 10 power minus 2, and the value of P plus Q by P is 10. The 10 power minus 2 in the numerator and the denominator gets cancelled. When you multiply all the numerator and divide it by the denominator, we get V dash equal to 1.0283 volt. And the correction can be found as V dash minus V volt. So V dash just now we have found it is 1.0283, and the corresponding voltmeter reading is minus 1. So we have got the correction as 0.0283 volts. In the same way, we can calculate for the other readings too. We will get the V dash like this. See, for the voltmeter reading of 1 volt, we have got 1.0283, and for 2 volts, our corrected voltage is obtained as 2.0173. For 3 volts, it is 2.9335. In the same way, for the 10 volts, the corrected voltage is 10.0135. By comparing the voltmeter reading and the corrected voltage V dash, we could see both the readings or both the values are almost close to each other. See, if you do the corrected voltage for 1 volt, the result obtained should also be around 1 volt. If you are doing it for 5 volt, the corrected voltage should also be nearer to 5 volt. So if you do not get it around the same value, then you are going somewhere wrong. Now look at the correction V dash minus V. For the first value it is 0.0283 and the second value it is 0.0173, and for 3 volts the correction is minus 0.0665. Do not worry if you get the correction in negative. You can get all the correction values either in positive or a negative or the combination of positive and negative. So here we have got the correction both in positive as well as in the negative values. And when you do a correction, the correction should be around or less than 0. Not more than 0.5 volts, or you can say it's not more than 0.2 volts. So when you do a correction or do a calibration graph both for the low range voltmeter as well as in the high range voltmeter, the correction obtained should be less than 0.2 volts. If you get more than that, then the correction is more and we have not calibrated it, or it is not good to use that voltmeter for the experiments. Now let us draw the calibration graph. Take a graph and divide them into 2 quadrants. Here, since our correction is both in positive, has both positive and negative values, here I have taken both the positive quadrant and the negative quadrant. So I have divided the y-axis into positive y-axis as well as the negative y-axis. We know along the positive x-axis the voltmeter reading V is taken, and along the y-axis the correction V dash minus V and volt is taken. So then we need to choose the appropriate scale. For our set of reading, the appropriate scale along the x-axis is 1 centimeter is 1 volt. So looking at the readings itself, we can see it is increasing in the steps of 1 volts. And the y-axis, and we have chosen 1 centimeter is 0.02 volt. And this experiment, doing the experiment is very easy and doing the calculation is also very easy. And the maximum mark goes for drawing the graph. So you have to choose a scale which includes a reading corrected to a third decimal. This is very important. The evaluator sees to it whether the graph is drawn to the corrected to the third decimal. So an appropriate scale is chosen. Then the scale readings are marked in the graph. So along the x-axis the voltmeter reading 1, 2, 3, 4, 5, 6, 7, 8 till 10 it is marked, and on the positive y-axis it is 0.02, 0.04, 0.0608 is marked, and on the negative y-axis minus 0.02, minus 0.04 till minus 0.2 is marked. Then this is the value for which we are going to plot. So it is voltmeter reading V versus correction V prime minus V. So the readings are noted here. These points are plotted now. See, for 1 volt it is 0.283. See, it is 0.02. For 8th reading, 0.028. In the fourth line it is pointed. The same way for 2 volts it is 0.173. So it is the fifth line is 0.01 and 0.7. We have rounded. It is plotted at 0.16. That is the nearest value we can plot it in the graph. And third point is minus 0.0665 So it is minus in the negative direction of y-axis, it is minus 0.66. Okay, in the same way we need to plot all the points. After plotting, we will get a points like this. After plotting all the 10 points, 10 values, you will get a points like this. Then join the points from 0 to 1 and 1 to 2, 2 to 3. So without leaving any points, you connect it, we'll get a graph like this. We'll get a calibration graph like this. So the important part in doing the calculation of this experiment is graph. So we have drawn the calibration graph now. Now let's write the result. Always note, result carries some mark. For example, during evaluation, 5 marks are allotted for this experiment. Many times students used to draw the graph and they fail to write the result. So the result should be written like this. The high range voltmeter has been calibrated for different voltmeter readings on it, and we have drawn the calibration graph.